Okay, very good morning, guys. Welcome back to the Boosted Statistics and Business Academy's Calculus series. We've been going through this one for a long period of time. We've been discussing that heavy question, complicated, heavy, and unusual, appealing, some kind of very interesting problems found in calculus whole series for a long period of time. So today also that we are planning to go through or that solve or that find a solution for one of the complicated integrals. Okay, let's go straight to the question. Thank you very much. Okay, this is my question. I'm going to write question here. Q. Evaluate the integral. Evaluate the integral. Let's say which integral that they are interested in. I equals phi ln sine inverse. I'm gonna get rid of this 5. Okay, we don't need the 5. Okay, if you want you can put 5 too. Okay, 5, that's okay. Inverse x over sine inverse x times 1 minus x squared dx. Look at the integral. Phi ln sine inverse x, sine inverse divided by sine inverse x times square root 1 minus x squared. How do you get this done? Here today we're going to talk about or discuss 3 methods. Okay, let's straight go to the first method. Fancy A for the answer. This is for the fancy Q for the question. This is for the answer. Method 1. Method 1. Using the formula. What kind of formula? Using the formula. What that means? Which formula they're talking about? Which formula? There's a formula. Say if you have an integral, some kind of a function gx to the power of n, and its derivative, the inside derivative, this functions, this composite function's derivative, right next to that one, in this format, you can simply write your answer like this way. You get the gx, same thing, and you're going to raise that to the power of 1 more than being given. See, 1 more than given, and divide by the same thing plus c. That's the formula. See, that's the formula. To check that whether that our given problem gonna fit into that formula, we have to separate the given function. This whole function has a several parts. So the function has a function. This function we little bit split and then see which one we're gonna take like a gx, which one we're gonna take like its derivative. Okay, let's see how to do it. See, I'm gonna little bit write I'm gonna pull out phi for sure. Which one look like which ones we're gonna make like a g of x? This guy or this guy or that guy? Look like if you have to find out some kind of a function whose derivative would be right next to that one. If you get this function and then look for the derivative, you know its derivative would be 1 over sine inverse x times 1 over 1 minus x squared. So that should be the g. Look like, see, sine inverse x, see, to the power of 1, see, power of 1. The rest I'm going to write like this way. See, 1 over sine inverse x times 1 over 1 minus x squared dx. I did that one for certain reason, thinking that I'm going to take this one as a g. Okay, let's say, look at, see, the note we can say gx, gx would be your ln sine inverse x. See, the note you can write this way. Note, let gx would be ln sine inverse x. Let's check its derivative. Let's check the derivative. Okay, let's check the derivative. Let's check the derivative of that particular function. First derivative with respect to x. Okay, see, ln, this whatever inside, you can write, see, 1 over that thing. We know that. See, whatever you have inside, 1 over whatever you have inside. We're not done yet because it has been done with respect to this whole thing. Then that should be differentiated with respect to x from the chain rule. That means, what's the derivative of this guy? Derivative of this guy would be nothing but 1 over 1 minus x squared. This is nothing but the derivative of this guy. I'm going to indicate derivative by prime. See? So it seems like this is gx, this derivative right next to that one. See? So it looks like this is gx, see, to the power of 1, and we have its derivative right next to that one. See? Therefore, we can easily write, see, I 5 times ln ln sine inverse x whole thing 1 2 times 1 over sine inverse x times 1 over 1 minus x squared dx. It's nothing but, this is like my g of x, okay? This g of x. This whole thing like my g prime x, see? Then I can write gx to the power of whatever the power we had earlier, 1 we had, 1 plus 1 over 1 plus 1 plus c. Now you can replace gx, that's it. Then we're done. Then gx is nothing but, oh, we have a 5 too, okay? I'm going to write the 5. Then 5 over 2, gx is nothing but ln sine inverse x whole thing to the power of 2 plus c. That's it. Okay? That's the answer. Very easy, not hard. That's the answer. That's the answer. Okay, then let's go ahead and look at the second method, how to get this done. Okay, you can get this done using what? U substitution. Okay, U substitution. U substitution. Very easy. Let's use the U substitution. By any chance, if you want to use the U substitution, you can use the method 2. Okay. Using U substitution once, okay? Once. We are planning to use the U substitution once. Once. Substitution once. See. Substitution once. So which one we're going to take as a U? Same like what we got for the G, no? Can you remember? I'm going to write down the I again. I is nothing but 5 times ln sine inverse x 1 over sine inverse x 1 minus x squared dx. See? So again, you can say this part is u. See, let u equals ln sine inverse x. Ln sine inverse x. The very moment you put u, that means we are planning to work with u rather than work with this heavy function of x, trying to replace. That means we really need, its operator has to be changed to, I'm going to differentiate both sides with respect to their respective operators. This side you get du, you put the operator, okay? This side you get 1 over sine inverse x times, you're not done yet, from the chain rule, you're going to take the derivative of sine inverse x, which is 1 minus x squared, and put the operator. See? So it's easy. Now you go back to this function, you can easily see, you get the whole thing, okay? With the whole thing, you get back to this one, you can pull out phi integral. This thing is nothing but u, see, u. This whole thing is nothing but, see, this whole thing is du. This thing is u. Very easy. See, du means that whole thing. So this is just simply du. You can end up with a very easy integral. See, and this means nothing but we have a phi already, u squared over 2 plus c. That's it. Then replace u with what? U with ln sine inverse x. Okay. Ln sine inverse x. That's it. See, phi over 2. See, ln sine inverse x to the power of 2 plus c. That's the answer. Using u substitution. This is using u substitution once. Let's say by any chance you don't know, you have to use a third method, using u substitution. Method 3, using u substitution twice. You're going to use that on 2 times. But that means we have an integral like this, okay? Phi ln sine inverse x 1 over sine inverse x 1 minus x squared dx. We have this one. Sometimes by accident, instead of taking the whole thing as a u, you're going to take this one only u. Still okay. That's why we are still okay by accident. If you take that one, okay, this part only, see, let u equals sine inverse x this time. Instead of taking ln sine inverse x, you take the only sine inverse x part as u. As we did earlier, very moment that you put this one, you have to take the operators on both sides. Du, on this side you have 1 minus x squared dx. See, Then let's replace this one. I, phi, I'm going to pull out ln u, because sign inverse x means u. See, this is u. This is u. This part, up to this part, whole thing is du. See, this part, whole thing is u again. See, so you have times 1 over u du. See, it comes like that. See, it comes like that. See, phi ln u 1 over u du. So what I'm going to do right after this one, at this stage, you saw that earlier, I used the formula. Either you can use the formula at this stage again, because you can use this again a little bit heavy, or you can use the substitution again. See, you can use formula, or use subs. I'm going to say substitution for the substitute. Okay, again. See, either way. If you use the formula, you can take something and see its derivative right next to that one. You see, I'm going to go ahead and see. You have a phi here, ln u here, 1 over u here, du here. You see, if you take the derivative of the whole thing, okay, I'm talking about the whole thing, okay, to the power of 1. This is the power of 1. You see, it's right over there. See, ln u with respect to u is 1 over u. The formula say what? If that's the case, ln u, whatever the function you were interested in, should be raised to the power of 1 more than the power it has. See, it's already there 1. I added another one plus c. So this is nothing but phi over 2 ln u plus c. See, plus c. Then you can be easily replaced by whatever you assume in the beginning. Okay, I'm going to write here phi over 2 ln sine inverse x plus c. See, you get the same answer. Or you're going to consider something as this whole thing, this whole thing as v. See, another letter, let v equals ln u. See, v. The very moment you put the v substitution or u substitution, you have to use dv on this side, 1 over u du. See, so that means I means phi integral ln u is v. See, whole thing is v, and 1 over u du, whole thing is dv. See, dv. Then you can see very basic integral. Then you can easily integrate this on phi v squared over 2 plus c. Then you can replace v. Phi over 2, v is nothing but ln u plus c. Then you're going to replace u. It's nothing but phi over 2 ln sine inverse x plus c. See? You're going to end up with the same answer. See, by any chance that you're going to consider that inside function called the argument function, which is sine x as a u, or the whole thing, ln sine x as a u, doesn't matter. You're going to end up with the answer. You don't get lost, okay? So let's look at another method. By any chance, you might be thinking, why in this way? Can't we get this done by integration by parts? Yes, let's try that one. Integration by parts. Okay, that's the fourth method. In integration by parts. Integration by parts, or integration by parts formula. Integration by parts formula, let's say like that. But it says integration, this is my function, this is my I. 5, you can pull the 5 out, okay? ln sine inverse x times 1 over sine inverse x 1 minus x squared dx. Now you have to figure out, we know that the integration by parts formula is, that formula says what? If you have an I in this format, u and dv format, you can say u v minus integral v du. Then you have to figure out which one's going to be u, which one's going to be dv, and which one's going to u means you need the operator. Convert to operator means you take the derivative, see, to get du, u to du, dv to v. From dv to v, you get to integrate. Then from this big function, complicated function, you're going to figure out which part going to be your u, which part is going to be your dv. Think about. Let's say that you have to think about a certain function that can be differentiable as u. Which one is u? If you get this guy u, this guy u, its derivative would be what? 1 over sine inverse x times 1 over 1 minus x squared, whole thing, see? So you can think about no, getting u. uv, then dv, 1 over sine inverse x. See? Which one? If you take this guy, and the dv should be this whole thing. Once you integrate that guy, what do you get? 1 over sine inverse x. See, this part you can take as a like a, see, u, let's say u, okay? Then you can write down its derivative, okay? Look at what I'm gonna do, okay? Let u equals ln sine inverse x, okay? Then you're gonna take the derivative. I put that sign to take the derivative. Du, this side you have a du, this side you're gonna have 1 over sine inverse x, okay? Sine inverse x times 1 over 1 minus x squared dx, see, that's du. Okay. Then what is dv? dv has to be this whole thing. 1 over sine inverse x 1 minus x squared dx. To get the v, you have to integrate. This is a sign for integration. That means you have to integrate both sides. See? So you integrate, dv integrate, this side also integrate. 1 over sine inverse x 1 minus x squared dx. See? What do you get for v? You get for v minus, see? See? Integral of dv. V should be what? This one would be, if you integrate this one, that would give you what? Whose derivative would be that? ln sine inverse x. You know that. See? That's ln sine inverse x. ln, if you have some kind of a function, you know this one, okay? I'm showing. What's the integral of 1 over x dx? Say ln x. Okay? That one. Then I'm going to a little bit change this one to this one. What's the derivative of 1 over gx, and on the top you have a u g prime x. Top means right next to that one. Okay, I'm going to write this 1 over gx times g prime x dx. What would be the answer? ln gx. Pretty much the similar fashion. Look at here. Sine inverse x. I'm talking about this gx, okay? Sine inverse x. Do you have its derivative right next to that one? Yes, I can see. I can separate it and write like this way, okay? Look at how I'm going to write. 1 over sine inverse x times 1 over 1 minus x squared. See, this is like my gx. Its derivative is right next to that one. That's why I put ln sine inverse x. See, same from that one, that formula, from this formula, okay? From that formula. See, you have a gx, you saw here, okay? For that one, that's how we get that. Now you're going to plug in into this formula, okay? Let's plug in into that formula. U ln sine inverse x v is ln sine inverse x, see? Minus integral, we have phi too, okay? I'm going to write the phi here. This whole thing for phi, okay? Then v ln sine inverse x times du. Du means, see, 1 over sine inverse x 1 minus x squared And I'm going to write the dx on the top, okay? See, like that. Close it. Sorry. Is that right? You have a 5 ln sine inverse x, 5 ln sine inverse x. Then what is this? No, I'm gonna distribute first. Okay, sorry, not yet. I 5 times the ln sine inverse x, the whole thing square. Whole thing square. Okay, whole thing square. Whole thing square minus 5 times, see, ln sine inverse x 1 over sine inverse x times 1 minus x squared dx. See, this is nothing but I again. See, I again, you can remember. That's what we assume as of I. So that means you have I equals 5 times ln sine inverse x whole thing being squared minus I. Then this I you can bring to this side, I plus I. See, I'm not going to integrate anything anymore. Ln sine inverse x whole thing squared. Then 2I is 5 times ln sine inverse x whole thing squared. So then I means what? Excuse me. I is nothing but 5 over 2 ln sine inverse x whole thing squared. See, we got the answer. Look at, we got this done by using 4 methods. 4 methods. There's no magic. Okay, very easy. Just follow the steps carefully. Write everything clearly. Get the absorb everything, digest everything, introspect everything, contemplate about everything. And at the end of the day, you can be a like expert in mathematics, especially calculus series, and then you are very confident that you can get a good grade, you can do so many things, so many integration, some slight mistake, that doesn't matter, but still don't give up, okay? So I'm gonna meet you guys again, like a video like this, another video like by going through questions like this. Until then, I want you guys to have a great day and stay safe, be well, okay? Take care, bye-bye, see you next time. Thank you very much. Okay, bye-bye. Okay, see you next time, see you. Good. Okay, bye-bye.